Welcome to my presentation. My name is Leah Lusk, and I'm doing mine on natural selection. All right, so let's get started. Natural selection is a mechanism of microevolution, which is a generation-to-generation change in frequencies of alleles in the gene pool, which makes it a pattern of selection as it decides the fate of the phenotype. This is going to happen when the Hardy-Weinberg equilibrium is broken and the population is going to evolve. So let's analyze a couple different types of selection. So let's get started with natural selection. And first, we're going to need three conditions, which let's see if I can zoom in. Variation and phenotypic traits must exist in the population. That makes sense. Differences in phenotype influence the probability of survival or the reproduction, and differences in phenotypic traits must be at least partially heritable. Now I'm going to include this image here, the starting population with the fur color, just so if that helps you follow along with the different kinds of selection. I don't find them super helpful, but it's kind of what a lot of textbooks use, but I'm going to give simpler to me examples along the way. So let's start with directional selection. Directional selection is a process in which one extreme phenotype is favored over the other extreme and the intermediate trait. So this is going to lead to a shift in the population toward the favored phenotype. An example of that I like is giraffes evolving to have a longer neck to reach leaves in really tall trees. It could, also go the other way if trees were really short. It could be the other extreme, but you're only going to see this type of selection favor one extreme phenotype, and that's going to be the long neck. And this is going to result in the variation of traits and the shift towards the population toward the favored phenotype. So the starting population we see here, if that helps you, these colors are one extreme or the other, but you're not going to see both. All right, in contrast, let's go to stabilizing selection up here. That's going to be a process in which intermediate phenotypes are favored over the extremes, leading to a reduction in variation in the population and the maintenance of average phenotypes. So an example of that is human birth weight, and that's going to be, common sense of why we're going to prefer the intermediate birth weight, because they have a higher chance of survival. I also like the bird's nest here as an example. Birds aren't going to lay too many or too few of eggs, because too many and there's not enough resources to feed them, and too few and there might not be any that survive. Effects of stabilizing selection are going to be maintain that status quo basically, and it'll reduce variation and maintain the average phenotype in the population. Once again, we can see our fur color here, maintaining that middle ground. And lastly, in the natural selection area, we have disruptive selection. This is either extreme. You can have one or the other is going to have a greater fitness than the intermediate. So like these three fish here, you're going to see the small fish and the large fish prevail over the intermediate size fish. And this could be because the larger fish is a better fighter, so he's going to be a lot stronger and have that advantage. The small fish is actually able to be sneaky and go fertilize eggs without being caught. So it's going to have the advantage, but the medium sized fish does not have either of those. So you're not going to see as many of those. So that is natural selection. And I do want to mention that even though these adaptations result from a process allowing individuals to better suit their environment, like we saw with the finches in the Galapagos Islands, evolution is also influenced by other mechanisms that aren't the environment that can alter gene frequencies, such as genetic drift and random mutations. Natural selection can also shift the traits favored within the population depending on environmental factors, and that can favor different traits in different subsets of populations. In some cases, selection can even have a swift and widespread impact, promoting traits that improve survival or reproduction through a population. So there's many different variations. I can't go through them all in 4 minutes, so let's keep going. Artificial selection. Obviously, it's not natural, it's artificial. Humans love to alter things to better their life. And we're going to see that in food and animals, probably humans one day. Breeders are going to intentionally choose individuals with economically favorable traits to use as breeding stock as they impose strong artificial selections on those traits. And that's going to go through, you know, um, a list of things they got to do to actually get those traits to be entirely or consistently in the population, which is going to take some work. You're going to have to start with the population of organisms that exhibit that variation, choose them, mate them, repeat it over and over. Many generations takes years. Over time, the frequency of that trait will increase, and then hopefully, you'll get the desired effect out of that. But yeah, that is the quickest explanation of natural selection ever. But I hope it helped make sense to you as this helped make sense to me. And yeah, how do I quit recording? Thank you. Goodbye.